In the last video, we talked about different strategies to find all the roots of a polynomial. Factor theorem, remainder theorem, the rational root test, polynomial long division. When we finished, we actually ended up with a quadratic that gave me complex roots, and we want to kind of expand on that a little bit more. And there's what's called the conjugate pairs theorem. And essentially, all the conjugate pairs theorem says is, if you're solving a polynomial, if you get some complex number, a plus bi, as a root, then its conjugate, which is a minus bi, also has to be a root. That should be pretty obvious because the only time we get complex roots is when we're solving quadratics out. And the quadratic formula always gives me two roots. So if we ended up solving the quadratic formula like we did last time, we got something like 1 plus or minus root 3i. But again, the quadratic formula has this plus or minus in it, which gives me two roots, 1 plus root 3i and 1 minus root 3i. So whether we state this theorem, the conjugate pairs theorem, we've actually been using it repeatedly. Anytime you get a complex number as a root, you get its conjugate as a root. They always come in pairs, which allows me to kind of solve different type problems. Suppose I have this. Suppose I tell you we have an 8th degree polynomial and I tell you that 1 is a root of degree 2, 3 is a root of degree 1, negative 7 is a root of degree 1, 6i is a root, and 2 minus 4i is a root. What are the other roots? Well, right off, how many have I been given? There's two ones, so that's 2, 3, 4, 5, 6. So I've given you 6 roots. You need to find 8 roots because it's an 8th degree polynomial. What are the 2 that are missing? And the trick is, well, 6i is a complex number, which means if it's a root, then its conjugate, negative 6i, has to be a root. 2 minus 4i is a root, which means its conjugate, 2 plus 4i, has to be a root. And there we go. I found 2 missing roots. I had 6. 6 and 2 is 8. So I found all my roots. That's essentially how we use the conjugate pairs theorem. It'll come up either in problems like this when you're looking for missing roots given some complex numbers, or when solving out a polynomial, but essentially they'll just come about when you solve out the quadratic formula, and you'll end up getting complex solutions the same as we've gotten them throughout the semester. They'll just happen to be complex. So ultimately, the goal of all of these theorems, in this video and the last few videos, is for you to completely solve a polynomial. We're not going to do it right here, but the idea is if I give you some polynomial like x to the 4th minus 4x cubed plus 7x squared plus 2x minus 2, can you find all the roots? There's 4 of them. What would you do? I'm going to leave this up to you guys to actually solve out, but essentially the idea is, well, it's a polynomial, integer coefficients. There's 4 zeros because it's a 4th degree, so find all 4 of them. Since the coefficients are integers, the rational root test applies. So find all possible values of p, all possible values of q, then find all the p over q's. Then, using the factor theorem and the remainder theorem, plug them into the polynomial, all the p over q's. If any of them give you 0, then you have a 0. That's associated with a factor, which you can then do long division using that factor on this 4th degree, reduce it to a 3rd degree, keep on going down. Ultimately, try to turn it into a quadratic, and once you have it as a quadratic, throw it into the quadratic formula and solve. I am aware that your calculator can actually do all of this work for you, Ultimately, I want you to do things algebraically and write them out algebraically using the tests. If you want to use your calculator as a check, especially when doing the rational root test, when you have 10, 20 possible rational roots to check, you can use a calculator as a guide. Oh, it looks like it's got a 0 somewhere around 1, so I'll look at all the P over Q's right around 1 and kind of just use it as a guide to help you figure out what the rational roots might be. But don't just plug stuff into your calculator and hit enter and have it do all the work for you. The goal is for you guys to learn the algebra and to be able to do it out.